In this video, I'm going to introduce you to what is called a logarithm. But to get our brains going, we're going to think a little bit about exponents. Let's see if we can answer these four questions. What must 3 be raised to get 81? That's a great question. Let's write that as an equation. What must 3 be raised to? So 3 to the what power is going to equal 81? What must 3 be raised to? Well, I know that's going to be 4 because 3 to the fourth is going to equal 81. What must 2 be raised to get 8? What must 2 be raised to get 8? Well, I know that's 3 because 2 cubed is 8. What must 5 be raised to get 25? What must 5 be raised to get 25? Well, 5 squared is 25, so that expression must equal 2. What must 6 be raised to get 216? These are getting a little bit harder. 2, or what must 6 be raised to get 216? I know that's going to be 3. All right, so we thought a little bit about exponents. Now, instead of writing out what must 3 be raised to get 81, we could write this expression as a logarithmic equation. All right, so let's think about this equation I wrote up here. The answer here is going to actually be 4. Well, how does that make sense? How do I write this exponentially? Well, I wrote over here 3 to the what equals 81. Well, I know that 3 to the fourth equals 81. So that means that these equations have to be equivalent. Well, that's interesting. Let's look at a definition. The formula for converting logarithmic to exponential equations, and this represents the definition of a logarithm, is log base b of a equals x. Log base b of a equals x. Okay, so b is what's called our base. A, the number inside here, inside the log, is what we call our argument. A is called our argument. And my x, which is the value of the log, is called my exponent. This is always going to be my exponent. So now when you're thinking about logs, logs are equal to exponents. Let's switch this to exponential form. Well, log base b of a equals x. That is equivalent to b to the x equals a. And my exponent is always focusing on the log. Now, I think about this in kind of an interesting way. I always think about a canoe, and I know that you have all, hopefully, at least seen a canoe in your life. And it's a little trick, but I look at it like this: b raised to the x is equal to a. My base raised to my exponent is equal to a, and again, my a is called the argument. So in the next two portions or sections, we're just going to focus on switching our forms. Rewrite the following exponential equations as logarithmic equations. All right. Now, the base of my exponential expression is going to be the base of my log. These b's are the same. So I'm going to write this as log base 4. My exponent, my 3 here, is always going to be what my log equals. Logs equal exponents. My a here, my argument, in this spot, is going to be my 64. And again, my exponent is going to go alone. So the b, which is the base of the exponential expression, is the base of my log. My exponent 3 is what my log equals to, and that value on the right side is my argument. Now, how do I do a quick check? I'm going to look at my canoe. 4 to the third is supposed to be equal to 64, and that is what I have here. 4 cubed is equal to 64. Let's try another example. Rewriting this exponential equation as a log. All right, I have my word log. My base of my exponential expression, my 7, is going to be the base of my log. My exponent, which is 2, is going to go by itself. And the value on the right side, that 49, is my argument. Checking with my canoe, 7 to the second is equal to 49. All right, I would like you to pause the video and try number 3 and 4 on your own. Okay, let's see how you did. Rewriting these in logarithmic form. My base of my exponential expression is going to be the base of my log. The exponent, the 4, represents my log, so that's going to go on the right. And the value on the right here, this 6,561, is going to be my argument. 6,561. All right, here, my base of my exponential is my base of the log. My exponent, my 0, goes on its own on the right, and the value on the right here is my argument. Do a couple quick checks. 12 to the 0 equals 1. Yes, it does, because any number raised to the 0 power equals 1. This one as well. 9 to the 4th does equal 6,561. Let's go the opposite way. We're now going to rewrite each log equation as an exponential equation. So let's think this through. My base of my log is going to be the base of my exponential expression. The base of my log is going to be the base of my exponential expression. Okay, I'm going to erase this little canoe over here. All right, so that means I'm going to have 4 raised to the value on the right, again, is my exponents. That's going to go up here, and the argument is what's going to go on its own. So that's saying 4 to the 5th equals 1,024. Check that with my canoe. This is saying 4 to the 5th is equal to 1,024. Number 6, the base of my log is the base of my exponential expression. Exponents are what logs are equal to. A log is always equivalent to an exponent. So it's equal to 3, so 3 is going to be my exponent. In the argument, this 512 always goes on its own. Quick check with my canoe. 8 to the 3rd does equal 512. All right, take a second and try 7 and 8 on your own. Okay, hopefully for number 7, you got 2 to the 5th is equal to 32. Again, because your base of the log is 2, that stays the base of my exponential expression. My log is always equal to the exponent, so this 5 goes in that exponent spot, and then the argument goes by itself. Same with this last one. I'm going to have 17 to the 0 equals 1. My base of my log is my base of my exponential. The exponent is what the log is equal to, and the 1 was my argument.